Math 76, lesson 123, square roots of numbers greater than 100 and functions. So let's start with square roots of numbers greater than 100. Let's see here. We're starting off with this example of 400. So there's a couple of ways we can do this. The most advanced method is using something called factor trees, which we're actually not going to learn this school year. So we're going to use what's called the cut and try method, or what I like to call the engineer's method. Or some people in the past, they call this the method of exhaustion, which is where we just plug in different numbers until we find something that works. So let's start with the square root of 400, right? Now, we don't just have to guess random numbers. We can be very smart about how we choose these numbers, right? We can use some things that we know for a fact. Like, for example, I know for a fact 10 times 10 is equal to 100. So I know the square root of 400 has to be bigger than 10, because 10 times 10 is 100, okay? So I can start trying some bigger numbers, right? The other way that I could do this is I could look at this lead number. The lead number is 4. I know what the square root of 4 is. The square root of 4 is 2, right? So I could try 20 times 20. That might work out for me, right? So let's test 20 times 20. If I were to multiply 20 times 20, I end up with 0, 0, 4, 400. Hey, it works out. I just found the square root of 400. It's 20, right? So sometimes testing that first number will help us find it very quickly. Other times, not so fast, but it'll still help it'll still be faster than us just guessing random numbers in the dark. So let's try a more difficult one. Let's say we have to guess the square root of 625. Okay, so I'm going to use that lead number thing. So if I had to do the square root of 6, well, let's think about it. We know that the square root of 6 is going to be greater than 2, but it's also going to be smaller than 3, because 3 squared is 9, so this would be 9, that's 4. Square root of 6 has to be somewhere in between 2 and 3, right? And since I'm in the hundreds, and I know that the square root of 20 is 400, then I know the square root of this has to be somewhere in between 20 and 30, right? Because 3 would give me 900, and that's too big. So it's got to be a number somewhere in between 20 and 30. So I can start trying numbers in between. Now here's the other hint that I have. This number ends in a 5, right? So what numbers times themselves end in a 5? This is where it comes in handy to know your perfect squares. So I could test 21, 22, 23, 24, 25, 26, 27, 28, 29, or I could know that 1 squared ends in a number with 1, 2 squared ends with a number that ends in 4, 3 squared ends with a number that ends in 5, 4 squared ends in a number that ends in 6, because 4 squared is 16, 5 squared ends in a number that ends in 5, because 5 times 5 is 25, which means the last digit will always be 5, right? So we can use that. So it's a very good bet that since this number lies in between 20 and 30 and it ends in a 5, it's probably 25. Let's try it. 25 times 25. 5 times 5 is 25. Carry the 2. 5 times 2 is 10, 12. Add the placeholder 0. 2 times 5 is 10. Carry the 1. 2 times 2 is 4. Plus, what is it? Plus 1 is 5. 500. Add these. 5 plus 0 is 5. 2 and 6. 625. We've got it. The answer is 25, right? Let me see if I can find a harder example. Okay, this is a tough one. I don't think your book will ever give you a problem that's hard, but I'm going to show you how these same rules can help you figure them out. So our lead number is actually 13, right? Because we're going to go into the hundreds place. So I think, what in the world is the square root of 13? Well, the square root of 13 falls in between what two square roots? Let's count by my square roots. 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16. This is going to fall in between 3 and 4, which means my answer is going to fall in between 30 and 40. Now that I've figured out the tens value, I'm going to look at this last digit. Remember, I'm going to look at this 9. Now, what perfect square ends in a number with 9? So let's count by my perfect squares. 2 squared is 4, 3 squared is 9. Ooh, do you think it'll be 3? That's possible. Let's try 33. Okay, so let's do 33 times 33. That gives me 9, 9. Carry the 0, that gives me 9, that gives me 9, and then when I add these, I get 9, 18, carry the 1, 1,000, that's too small. Okay, so it's not 33, let's keep counting. There's only so many square roots that end in 9. Let's see here. 4 times 4 is 16, 5 times 5 is 25, 6 times 6 is 36, 7 times 7 is 49. Oh, 7! 7 ends in a 9. So let's try 7 times 7, or 37 times 37. Let's see here. 37 times 37. 7 times 7 is 49, carry the 4. 7 times 3 is 21, 25 plus the 4, placeholder 0, 21, carry the 2. 3 times 3 is 9, plus 2 is the 11. Add, 9 and 0 is 9, 5 and 1 is 6, 2 and 1 is 3, 1 is 1, 1,369. We got it. So the actual answer is going to be 37, right? So that's how we can estimate square roots that are greater than 100. Now let's talk about functions, okay? So functions, oh wow, I need to, I need a whole new piece of paper. Let's figure this out. Functions are mathematical relationships of things that we can actually represent in the real world, but that's a little complex for you guys. What we're going to do is we're just going to learn about how to compute functions and how they're written down. So functions are more or less like a mathematical rule that we can create for a number relationship. So for example, we might have the following function. It would be p is equal to 4 times s. Okay, so that would be our function, and then we would also have a chart. Let's say our chart looks like this. Right? And what this chart is going to show us is what happens when we pick different numbers for p and s, and how those relate to each other. So let's say the top column will be the p numbers, the bottom column will be the s numbers. So when I put 20 as p, what would the number be for s? Well, to figure this out, all I have to do is put these numbers into the equation. So instead of writing p, I'll write the number 20. Put the equal sign, the number 4 stays the same, and s, I got to find out what s is. So if I can solve this, I know what s would be. So let's see here, I'll just divide by 4. That cancels, 4 goes in 25 times. So s would be equal to 5. Cool. And let's say I picked some other numbers. Let's say I picked the next one. Let's say I said, I want to know what p is when s is 7. So what I do now is I would go back to the original equation, and instead of replacing p, I'm going to replace s. So I'll write p is equal to 4 times 7 now, right? So 4 times 7 is 28, so that means p would equal 28. So I go up here, and now my p answer is 28. Great, so this is how a function works. What your book is going to do is they're going to give you a functional equation like this. This is the function. They're going to give you a chart. They'll have a bunch of numbers written down. And then there will be one missing number with a question mark. Okay, so you'll start off with all of this. All you have to do is you go to the missing number column and you go, okay, well they tell me the number s. I have to find p. So you go back to your equation and you would plug in s in the s spot. So p is now going to equal 4 times 15, and then 4 times 15 gives me 60. Yep, 60. So that means this missing number is 60, and that would be the answer that goes right there. Okay, so that's how functions work. That's functional notation, and your book's going to have all kinds of different variations of this. So let's see here. Is there? Yep, we'll do one more example because these can get kind of difficult. Let's say we've got this example. What if they use only one letter, right? So let's say we've got, this is our functions graph. We've got x and then 3 times x minus 2, okay? And now we have to figure out what in the world this table is going to make when I add some missing numbers. So let's say that x goes from 2 to 3 to 4, and then I've got 4, 7, and a question mark. So what they're telling me is they want to test the x values for 2, 3, and 4. So what happens when x is 2? What happens when x is 3? What happens when x is 4? And then they want me to find that out in regards to this value of 3x minus 2. So what I'm going to do is I'm going to take this 4 and I'm going to plug it into that x position right there. Okay? So I would rewrite this as 3 times 4 minus 2. Well, now I use PEMDAS. 3 times 4 is 12, minus 2 is 10, so this answer must be 10. and that's my final answer. Right, so that's another way that they'll do it. Sometimes they'll give you a function table like this, and they won't tell you what the function is. You'll have to guess what the number is, or they'll want you to figure out what the rule is. So that might look something like this. What if we have a function table like this, where we've got, we'll say letter A, letter B, and we'll have the following numbers. We've got 3, 5, 7, and a question mark, and we have 8, 10, 12, and 15, right? So now what we can do is we can kind of try to figure out the trend of what's happening in these relationships. So what I can see here is that the bottom number goes up by 2 every single time. So it goes, oh no, it doesn't go up by 2 every time. It goes up by, it goes up by 2, 2, and then 3. So what in the world would this value be? The way we're going to do this is we're going to figure out what the rule or the relationship is from A to B, okay? So when B equals 8, A now equals 3. Now what could be happening here? Is it 3 times a number that equals 8, or is it 3 plus a number? I'm not sure. How does 3 turn into 8? Well, there's a couple ways we can do that. We could add 5, right? That seems to work, but now we have to make sure that it's true for the other values. So let's test it twice. If B is equal to 10, then A would equal to 5. Does that plus 5 rule that we did, does that work down here? It does. Okay, so from that standpoint, now that we've seen that this plus 5 works twice, we could go here and we could assume, hey, B is equal to A plus 5, right? So we could say the rule is B is equal to A plus 5. So when B is 15, so if B is 15, then A must be 10, because if I subtract 5, then I'd have 10 equals A. Yeah, so A must be 10, right? So that's how we're going to figure these out. We've got a few different ways to do these. They can be a little complicated. And, actually, wow, this is a long video, 12 minutes. But hopefully this helps you out in solving them. If you guys have any questions, let me know on the school website, and I will see you in class.